Let's do some more examples of simplifying our logarithms without a calculator. Here we're given log base 5 of 5 to the 8th. This does follow one of our log properties, our basic log properties, but let's say we forgot that that's just going to be the exponent. So let's go ahead and give ourselves an equation. We would have log base 5 of 5 to the 8th equal to our favorite variable. I'm going to use x because I really like x. Okay. We're going to do the Spidey method where we swing up to get our exponent. So we get 5 to the x is equal to 5 to the 8. Because our bases are the same, they can go away, and we find out that x is equal to 8. So this follows our log property that we just did. Back here, if you have log base b of b to the x, this is the one that we're looking at right now, this one right here, then that equals whatever that exponent is. But I did this problem without remembering that log rule. Okay. Next one, give yourself an equation. So we have log of 10 equal to x. Remember, if you do not see the base, but you see the entire word log, that is log base 10. So when we rewrite it, we're going to have 10 to the x equal to 10. And remember, if the exponent, you don't see it there, it is a 1. Now we have our bases the same, so they go away. And we get x is equal to 1. This again falls into the case of if you have log base b of b, that just equals 1. Another log rule that we had just covered. Okay. Let's look at our next one. We have the natural log of e squared, just like in the previous. I'm going to give myself an equation. So natural log of e squared equal to x. Remember, natural log comes from log base e. So we're going to do e to the x. When we use Spider-Man method to rewrite this, gets us e squared. And because our since our bases are the same, that means that our exponents better be the same, and we get x equal to 2. This falls into the log property of, scroll back up to it. Okay. The log base b of b to the x just equals x. So again, same formula, but I am not remembering the properties. I can go forward with this. The next one you're going to want to remember, but let's say you don't. We have log base 6 of 1 equal to x, and we rewrite it as an exponential. We would have 6 to the x equals 1. The only way that we can make something to a power equal to 1 is if that power is 0. I highly suggest remembering that if you have log of 1, it's automatically going to be 0. Next one, we have log base 7 of 1 all over 343 equal to x. Go ahead and rewrite this as an exponential. We get 7 to the x equal to 1 all over 343. And we're going to use our exponent rules. We want to rewrite the right-hand side to have the same base as the left hand. So we use our calculator and find out if we can rewrite 343 as 7 to a power. We're not going to do 7 to the 1 because that's 7. 7 squared gets us 49, but 7 to the third gets us 343. We can't get rid of the bases yet because this one in the bottom is not the same. We need to move him up. So we get 7 to the x is equal to 7 to the negative 3, changing the sign on our exponent. Now that our bases are the same, we can cancel them out using the one-to-one property of our exponential functions, and we get x is equal to negative 3. So our answer is negative 3. Last example. Oh, sorry, not last example, second to last example. Last example in this one. We have log base 64 of 2. Go ahead and rewrite that as an equation equal to x. Exponential form using Spider-Man, we get 64 to the x equals 2. We want to rewrite the left-hand side in terms of 2 to a power. So we go to our calculator. We know 2 cubed is 8. 2 to the fourth gets us 16. Keep using your calculator. You should find that 2 to the 6 is equal to 64. When you have an exponent raised to another exponent, that means you get to multiply them. So we get 2 to the 6x is equal to 2. And remember, if you don't see an exponent, it is a 1. Because our bases are the same, they go away. And we get 6x equal to 1. When we divide both sides by 6, we find out x is equal to 1/6. Last example, our first log equation where they're actually giving us an equation. We're going to solve this by converting to exponential form. So what they're asking us to do is to take our equation, rewrite it using Spider-Man method, and then solve it. So rewrite, we have 5 squared is equal to x plus 4. So we get 25 is equal to x plus 4. If you do not like that your x is on the right-hand side, you can rewrite this as x plus 4 equals 25. Remember, it's the same thing. We just move the 25 to the other side. It's like rotating your equation. But you subtract the 4 and we find out that x is equal to 21.